Hello everyone, thank you for joining me today for this week's Alteryx Challenge walkthrough. My name is Calvin, and I am a data analytics consultant at the Information Lab, where I primarily use Alteryx and Tableau. Today's challenge is challenge number 475, the Collatz conjecture. Now, if you were wondering, what is the Collatz conjecture? Well, Alteryx has provided an explanation and a definition of what this problem is. Let's go through that together before we begin the challenge. The Collatz conjecture is also known as the 3n plus 1 problem. It is an unsolved problem in mathematics that is simple to state but very difficult to prove. And it is defined as the following. We'll start with any positive integer n and apply the following rules. If n is even, we divide it by 2. If n is odd, we multiply it by 3 and add 1. We'll repeat this process with the resulting number as much as necessary to reach the number 1. And the conjecture states that no matter what positive integer n you start with, you will always eventually reach the number 1. Let's go through an example. We'll start with n equals to 6. Since 6 is even, we'll apply the even rule and divide it by 2. 6 divided by 2 is equals to 3. And since 3 is odd, we will now use the odd rule. 3 times 3 plus 1. That gives us 10. Now this will go through a few more steps until we finally obtain 1. And a total of 8 steps were required in this example. So this is the Collatz conjecture. And for this week's challenge, we are asked to create an iterative macro that simulates the steps above for reaching 1 for each number that we provided with. So the task is to generate the numbers from 1 to 10,000, use the iterative macro to apply the conjecture to each of those numbers from 1 to 10,000. We will also want to record the number of steps it takes for the Collatz conjecture to help each number reach the number 1. And we will also want to identify the maximum number of steps used to reach the number 1. So down below, we have the start file. So let's download that and go into Alteryx. Once we have the start file opened up, we'll see the challenge again, as well as its description. And we also have an output tool and a browse tool. So if I run this workflow and take a look at the browse tool, I can see that the max step that we want to see at the end is 261. So that means there is one number between 1 to 10,000 that took 261 steps to reach the number 1. Our first step is generate rows tool. So I will drag that down and customize it. And instead of row count, I want to create a new field called n, since that is what I've been calling positive integer n. I'll keep it as an integer 32, and the initialization expression will be 1. That means we are starting at 1. And the loop expression, I want to be n plus 1. So we are adding 1. The condition expression, I want to generate rows to stop when n is equal to 10,000. So if I run this, I will obtain 10,000 records going through 1 to 10,000. Now, I also want to duplicate this column to use as a reference. I am curious about which number it is that took 261 steps, so I want to create a reference number, which is simply n. We'll keep it as an integer, and this will give us 2 columns with n and reference. I am going to feed the macro n, and it will also output the reference after n has been transitioned in all to 1. So my next step now is to create the macro. And to do that, we need to go to a new workflow. And let's start by adding a text input tool. I am going to give it a sample data where the column is called n, and I will give it the values 1 through 5. That. And I want to make sure that this column is an integer type. So I will take a select tool. And right now I can see, since I have only included 1 to 5, Alteryx has given it a byte. But I know that I have large numbers, so I want to put int 32. We will run that. And now we want to bring in a formula tool to create the Collatz conjecture formula. We'll apply that to n. And the formula, it will be an if statement. And I'll be using the mod tool where it will give me the remainder of n divided by 2. If that remainder is 0, then this is an even number. And if it is an even number, I want to divide n by 2. Else if n divided by 2 does not return the output 0, then I want to use the odd rule, which is n times 3 plus 1. Else, no. End of. So that is my Collatz conjecture formula for when n is even and when n is odd. I'll run this. And let's take a look. So originally we had 1 for the record row 1. And since that was odd, we took 1 times 3 equals to 3 and add 1. So that gave us 4. This looks accurate. Now I want to bring in a filter tool that will stop the macro when n is equal to 1. So each time the macro runs, we want to bring the rows to the true condition. If it's not in the true condition, it will come through the false condition, and it will go through the Collatz conjecture once again until it reaches 1 and goes into the true condition. So now to create this macro, I need to add in some macro elements in here. And I will go to the interface and drag in the macro output tool. One for the true condition and one for the false condition. For the true condition, this is my final output, and I will give it an abbreviation of F. For the false condition, I want this to iterate again until it reaches the true condition. Iterate output, and I will give it an abbreviation of I. Now we have the macro outputs. Well, I need to also make the text input a macro input. So I will convert to a macro input. Now I also need to make sure that this workflow, while it is a macro, it needs to be an iterative macro. So I'll go to the workflow configuration, I'll click workflow, and instead of a standard macro, I need to change it to an iterative macro. Now I need to also set up the settings for the iterative macro. For the iteration input, I want the input. The input 6 is the input right here, the text input that I converted to a macro input. For the iteration output, I want to use the iterate output, which contains the false conditions. For the maximum number of iterations, I will select 300 since we know the maximum number of iterations or steps taken for a number to reach 1 was 261. So I will leave it as 300. Now there is one more item that I want to adjust here, and that is to add in the steps. So I'll go back to my formula tool, and I will add a new column called steps. And this will be engine iteration number, which will give us the number of times it has run through. And that will be iteration number plus 1 each time it runs. And we will need this to be an integer. So this is our macro workflow. Now I need to save this as a macro. I will do so by going to File, Save As, and Browse. I will now save it into a file and rename it macro for Alteryx Challenge 475. Now it is saved as an yxmc, which is a macro. Now let's go back to our original workflow, and we will need to pull in the macro. So we will need to go to Options, User Settings, Edit User Settings, and we will need to go to the Tools section. And let's add in the folder that we just saved the macros to. So once you have selected that, please click Save. And now Alteryx can pull in the macro that we have just created. Macro 475. That is our macro. So let's connect the input for the macro. And let's click Run. So now we have 3 columns. One is N, our original field. One is reference, and the steps. We obtained steps from the iterative macro. So we can see that 2 only took 1 steps, 4 only took 2 steps, and so on. Now we want to find the largest number of steps taken for a number to reach 1. So we can bring in the sort tool on the final, and there is no value for the iterative since everything has been completed before outputting to the final tool. For the sort tool, we will sort by steps and by descending. Let's run this. and we can see that the maximum number of steps taken is 261, and the reference was for number 6,171. So for this number, it took 261 steps to reach number 1. Now we can use a sample tool to filter down to the top row. First n rows, and n being 1. Run this, and we will obtain steps 261 for this reference number, 6,171. We can then also include a select tool to keep only steps and rename it max steps. Now we have max step of 261, which is exactly what we have seen in the original output solution, 261. We can also put a browse tool. I click run. Now, if you did not want to see the reference number and just wanted to see the maximum number of steps, you can also use a summarize tool from the transform, pull in the final outputs, and just obtain the maximum steps or max steps. So if you run that, you will also obtain the max steps of 261. This is Alteryx Challenge 475. I hope this has been helpful to everyone, and thank you for watching the video, and hope everyone have an amazing rest of their day.